I want to show you a trick, or not really a trick, but a tip for solving the Pythagorean theorem problems in ALEKS, because in ALEKS they give us a calculator to solve these problems. So I just wanted to show you how we go about doing this in ALEKS and using the calculator and then also using the formula. Right, so first of all, the formula, or what Pythagorean theorem says, is that when we have a right triangle, and a right triangle has a 90-degree angle, and that angle will always be denoted with this square in the corner. So when we have a right triangle, we use the Pythagorean theorem, which says that if the legs, which are the sides adjacent to that right angle, are have lengths A and B, then the hypotenuse, which is the side opposite or across from that right angle, has length A squared plus B squared equals C squared. So we would solve this for C. So basically, C equals the square root of A squared plus B squared. So I just wanted to start by writing that down. So when we have a right triangle, doesn't matter how you draw it, but I always like my right angle to be at the bottom somewhere. So here's my right angle. The sides adjacent are labeled A and B, and the side opposite is C. Then A squared plus B squared equals C squared. And then I could take the square root of both sides. So then I can get that C is the square root of A squared plus B squared. So now I can always use this to solve the problems using my ALEKS calculator. And then the other thing that happens, since I have A squared plus B squared equals C squared, if they give me C and one side, okay, so it doesn't matter which side I'm missing, but let's just suppose we're missing A, then this tells me that A squared equals C squared minus B squared. And then I can again take the square root of both sides. So A equals the square root of C squared minus B squared. And of course, B also equals the square root of C squared minus A squared. So basically, if they ask you to find the hypotenuse, you're going to take the square root of the sum of the two sides adjacent to the right angle. And if they ask you to find a side, you're going to take the square root of the hypotenuse squared minus the other side squared. And so once we know this, the nice thing is now I can just look at my equation here, and this is C, right? This is my hypotenuse. It is opposite my right angle. So I can call this whatever I want. So I can call this one B, and I can call this one A. So X is going to be the square root of C squared minus B squared. So then I can use my calculator. So X is the square root of C squared, 15. And I can use this, X squared minus 11 squared. And so the reason that that you can that I like to use their calculator is it always sets it up how you wanted it. And then also you can always check your answer. The hypotenuse is always going to be the biggest number. So when I go equals, this is 10.198. And this number needs to be less than the hypotenuse. So if you get a number greater than the hypotenuse, you did it wrong. And if you're given the two sides and you get a hypotenuse that's less than either of the sides, then you did it wrong. So that's how you can always check your answer. So this is a side, it is adjacent to the right angle. And then again, the hypotenuse is the one opposite of the right angle. And so the side opposite will always be the biggest one. And they want this rounded to the nearest hundredth, which is 2 decimal places. So I like to put my mouse in between there. This 8 is 5 or more. So I'm going to round that 9 up. That rounds up to, instead of 19, I get 20, right? So 19.8 rounds up to 20. So my answer is going to be 10.2. Put that in. 10.2. And then we will check our answer. Oh, okay, they're gonna, all right, they want me to add the extra 0. Kind of silly. Okay, more practice. So I just want to show you, now that we know how it works, we're going to do the same thing again. So they asked us for a side. So we're just going to use the calculator. And the answer for a side is the square root of the hypotenuse squared minus the other side squared. So we just put in square root 10 squared minus 8 squared. And that is 6. Wonder if this time, if it's going to ask me again to put in 6.00. Right, and let me see if they give us one with a hypotenuse. Nope, every time they're asking me to find a side. All right, so we'll do the same thing again. So they're asking again for a side. So it's going to be the square root of 17 squared minus 12 squared. And that is 12.04. Finally, now they asked us for the hypotenuse. So they asked us for the hypotenuse and the hypotenuse. So we're going to use this first formula. So we use our calculator. So x squared is the square root of 12 squared plus 10 squared, because it's the hypotenuse. So we're going to use the square root of 12 squared plus 10 squared. And again, the hypotenuse should always be the biggest side. It's opposite the right angle. So this is larger than 12 and 10. So that's how I know I did it right. And this is 15.62. And there you have it, a much easier way to solve your Pythagorean theorem problems.